Okay, so let's take this, f equals omega over 2 pi. Well, what was omega? We just said that our omega, here where you can see it, our omega is 2 pi. What do we have here? F equals omega over 2 pi, so F equals 2 pi, that's omega, right, over 2 pi. So F equals 1. And if F equals 1 over the period, then the period T equals 1 over F. Okay, and F was 1. And turn that so you can read it. I wrote it at an angle, sorry. But that gives us T equals 1 over F. Well, T equals 1 over 1 is 1. And what do we get here? T equals 1. So that worked out. Okay, that's nice. All right, let's continue on here. I think this is the last problem in our graphing. And now finally, we do not have a sinusoid here, okay? So we can't really use our standard form on problems that are not sinusoidal. It's not sinusoidal because secant is 1 over the cosine, and that's not a sinusoidal cyclic function. It has a different shape because it's like a reciprocal function. It's 1 divided by something, right? But our task here is to graph one cycle of this and state its period, okay? So remember, theta is always the argument of the function. So theta is 3x minus 2 pi, okay? And then we can solve for x. So theta plus 2 pi equals 3x. Theta plus 2 pi, that whole quantity divided by 3, gives us x, right? You just add 2 pi to both sides of the equation, and then you're left with 3x on this side. Then you divide both sides of the equation by 3. That leaves you with x by itself and all this stuff over here, which is just this. So now we know what x is. Given a theta, we know what x is. You tell me the value of this, I plug it in, I give you x, all right? Theta is the independent variable here. X would be the dependent. All right, so just for memory, secant theta is 1 over cosine theta. So to graph this, it might be a good idea if we go ahead and write out cosine theta. That'll give us a better idea of what's going on, right? Now, the thing we got to notice here that makes this graphing we have to be more careful with secant and cosecant functions, or tangent and cotangent functions, because we have a denominator in our expression, and the denominator is not allowed to be 0. So those are going to be undefined points. So we have to pay attention to that, okay? And so the cosine of theta is not allowed to be equal to 0. Where does that happen? Well, the cosine of theta is 0 anytime theta is pi over 2 radians plus any multiple of pi over 2, plus or minus, where k is an element of z. That means k is an integer. Okay, k could be a negative number, it could be 0, it could be a positive number. Okay, it can be any integer, positive or negative. So where theta is pi over 2 plus 2 pi k, those are undefined points. And also in a cosine function, there's 2 places where the cosine function is 0. It's also 0 at theta equal 3 pi over 2. And again, plus 2 pi k, where k is any integer, okay? So let's graph it. We do our standard thing. We want to graph one cycle. We're going to graph from 0 to 2 pi, and this is kind of slightly complicated. We can't just glance at it and immediately know what it looks like in a graph. Because of that, we want a little better approximation of it. So we're going to use these intervals of pi over 4. So pi over 4, 2 pi over 4 till we get to 2 pi, which is 8 pi over 4. All right, we've solved for x already here. So we plug each value of theta into our equation here, and we get what the x value is for that value of theta, okay, by just plugging each theta in there. Cosine theta, and that's why it's nice to write secant this way, because now we can use our wheel. Where's our wheel at? It's buried here. Anyway, you know what I'm talking about. Because we don't have anything about secants or cosecants or tangents on here, but we've got sine and cosine. So if we write things in terms of sine and cosine, we can go back to this unit circle or our wheel and get our, here we're going to need cosine values. So that's going to be the first value in these pairs, okay? And so we can immediately write down for theta of this angle, we can write down what cosine theta is. That's straightforward. Now secant theta, we know we have this relationship. It's 1 over the cosine of theta, right? So if we just take the reciprocal of this, if we flip it, which is kind of its inverse, if we flip it over the fraction, then we have the secant value for that fraction. We just have to keep in mind that we're not allowed to have places where the cosine is 0. So we're okay here. The reciprocal of 1, if we flip this over, we still have 1. We flip 1 over the square root of 2 over, we have the square root of 2. Our next value, the cosine of theta, is 0. That's a value that's not allowed, right? Because it makes this undefined. So we just write undefined for secant. Then we continue down our list. We take the reciprocal of each one, we write down the undefined. And now here, remember this secant 3x minus 2 pi is simply secant theta, and we've already got secant theta. So all we have to do to calculate y is add 4 to this number, and we're done. So this is 1 plus 4 is 5, y is 5. It's secant theta, 1 plus 4 is 5. Secant theta is square root of 2 plus 4. And here, use your calculator, and it's a decimal approximation of that number. Undefined, we can't do anything with that. That's a skip, not applicable. It's undefined. So we go through where we have a number, we write it where it's undefined. We make some kind of indication there that that's a no good number. And now we can make the graph. Okay. And going back, here's our x values. We're going from 8 pi over 12 to 16 pi over 12. And secant, or the range is going to be, it looks like 5.41 is our biggest number, and 3 is our smallest number. So here is the graph. And so what we've done, here's the individual points. Here is the first point. This is the x and the y value. So we just got, for x equals 8 pi over 12, y was 5. Okay, and then we get the next one. X is 9 pi over 12, y is 5.41. Here, this would be 5.5, where this next line on the paper is. Okay, and then the next point's undefined. Well, that's this vertical asymptote that the secant is it never gets there. It will approach that value. The x coordinate will approach that value, but you never get exactly there, because then you have 0 in your denominator, which is infinity. So that's why this is shown trailing off towards positive infinity. And you can plug just a couple numbers in your calculator, just figure out what number this is, and put another number in between here and here. Pick out an x between 9 and 10. So, 9.5 pi or 9.7 pi over 12. Just plug that in for x, and you'll see you get a higher y value the closer you get to this line. And so the next point after this undefined is 2.59. Okay, so that's x equals 3 pi over 4, y is 2.59. So 3 pi over 4 is the same as 8 pi over, let's see, 3 pi over 12 is 9 pi over, let me see, it's here, is 9 pi. 3 pi over 4 is 9 pi over 12. I'm just looking here. 2.59. Undefined. Oh, and this is at 11 pi over 12. I was looking at the wrong point there. I'm sorry. I was looking at theta, and I should be looking at x. The next point after this vertical asymptote, my mistake, I was looking at these and it wasn't adding up, which it won't because we're plotting x. Okay, so our next point, here was the vertical asymptote, right? It's a point where it's undefined. So as you approach that value, depending on whether you're approaching from the right or the left, if you're approaching from the left, the y value is going to increase exponentially. But if you're approaching this value from the right, the y value is going to be decreasing very, very fast the closer you get to this point. Okay, so the next point beyond this undefined point is x equal 11 pi over 12. That's here. Okay, and its value is roughly 2.59. So here's this point. And then we just continue to plot the points, okay? Then we come to the next undefined value, which is x equals 14 pi over 12. So this is undefined. So we know when we get to the next chunk that we're graphing, when we get past this vertical asymptote, we know we're going to have a high y value all of a sudden, right? And that's because what's happening there is this is going from cosine of theta is changing, okay? So what are we talking about here? We're talking about values around where cosine theta equals 0. Okay, at values around cosine theta equals 0, well, as far as the cosine function is concerned, if you're just to the left of that, you're going to have one polarity, and just to the right of that, you're going to have the opposite polarity, right? As this is approaching, so in other words, here's a value, this is cosine theta, and this is 0, which we're not allowed. This is where our asymptote is, right? So at these values, this is the cosine of theta is some small negative number. Here, it's less than 0. On the other side of this, cosine theta is a very small positive number. It's greater than 0, right? So we're dividing a very small negative number into 1. That gives us a very large number, but it's negative, okay? But as soon as we cross that point where cosine theta equals 0, then all of a sudden we've got a very small positive number, very small number, but it's positive, divided into 1 makes a very large number, okay? So as we cross this, as we get right at this point, it's undefined. We don't know what it is, but very close to this point, to the left of it, is a huge negative number, right? The closer to this point, the more negative it is. And just to the right of this is a huge positive number. So that's what we're showing there. So we went from 13 pi over 12 to our undefined point. We go from 2.59 to undefined. And our next point, we jump back up to 5.41 when we get past this undefined point. Here's our next chunk of x, okay? So this would be 15 pi over 12, and all of a sudden we get this 5.41 value here. And then our last data point, x equals 16 pi over 12, we get y is equal to 5.0, okay? So that is this function, a secant. And the period of the function, this function would actually repeat, right? So if you would go beyond this point, these would curl back up, and then you would have this pattern again. After that, you'd have another undefined point, and going the other way, you'd have a symmetric pattern, right? So this is one cycle. And what's the period of the cycle? Well, this is where theta was 0 and theta was 2 pi. X went from 8 pi over 12 to 16 pi over 12. So we go a total distance in x, which is its period, of 8 pi over 12, okay? Which is 2 pi over 3 would be the period t. And we don't really use the standard form with omega here because, and we don't do, there's no midline change because this isn't a sinusoid basically. Once you're into secants, cosecants, tangents, cotangents, you involve reciprocals of sinusoids here, 1 over the cosine. So we don't really use the amplitude in the same way, or the standard form in the same way. Anyway, that wraps it up for this problem 20. Graph one cycle and state its period, and we state the period here. So when we go through one cycle, x goes from here to here. So that's the period. Thank you very much. Have a great day. What we're going to be talking about next is inverse trig functions, just a basic overview of them, because you'll be using those in calculus and other classes when you're doing trig. And sneak peek. So the inverse of a trig function is simply instead of so the way we've been doing things is you give me an angle, and let's talk about cosine for example. You tell me an angle, I'll tell you what the cosine of that angle is. Okay. The inverse trig function, you reverse that process. It's the inverse of that process. So you give me a cosine of an angle, and I tell you what the angle is. So you're going in the opposite direction. You have trig function information, and you can determine what the angle is given the value of some trig function. So we need to go back and forth in both directions when we're dealing with applications of trigonometry. That's all I have. Thank you, and have a great week.